Hello, I'm Jason, and today we'll be going over cold agglutinins and a saline replacement procedure. What are cold agglutinins? They're antibodies that react at lower than body temperature and cause red cells to agglutinate. There are a variety of causes for cold agglutinin disease. Primary disease, which causes mainly unknown, or secondary disease that can be caused by bacterial, viral, parasitic infections, autoimmune diseases, or even some cancers. Analyzing cold agglutinin samples is similar to running any other CBC. Run the specimen on an analyzer and make a blood smear. Certain results such as RBC, HCT, MCV, and MCHC will be affected by agglutination if present. Some error messages you may get are macrocytosis, RBC agglutination, or turbidity interference. If a patient is known to have a cold agglutinin, it is best to keep the sample in a warm heat pack from the patient to the analyzer. You can potentially eliminate the need for a saline replacement if you keep the sample at body temperature. The pre-saline replacement results will look something like this. Next to some of the indices there's an asterisk. This is a flag letting you know that these results are unreliable and should not be resulted without further examination. The bottom of the page lists a few error messages such as macrocytosis and RBC agglutination, and upon examination of the blood smear, you can see that the red cells are forming large clumps. These flags indicate that you would need to perform a saline replacement to get accurate results. Performing a saline replacement has minimal steps and is a fairly easy process. I will demonstrate these steps for you now. Okay, so once you know you have a cold agglutinin sample, the first step will be to incubate it at 37 degrees for about 30 minutes. That will hopefully clear up some of the red cells sticking together and release the antibodies so you can spin them down and be able to remove them. So this is an incubator. Set a timer for 30 minutes. After your sample has been incubating for 30 minutes, take it out of the incubator and put it in the centrifuge, 2500 RPMs for 5 minutes. Okay, so after your sample's done centrifuging, let's take it out. See that the plasma is separated nicely from the red cells. And this step is a little more complicated than the others. So there's a couple ways to go about this. I've learned some tricks so far here. You can either use a couple of volumetric pipettes. You can see the volumes written here. You can use each one to remove as much sample as you can, taking note exactly how much you remove. If you remove one of these and 3 of these, you're going to need to be able to replace one of these and 3 of these in the saline. Another nice trick that some people have shown me here that seems to work pretty well is you take a Sharpie. I might be doing this terribly because I'm trying to hold the camera too, but if you draw a line exactly at the top of the plasma, being as careful as possible, you can mark it, and then you can take one of these pipettes and remove all of the plasma off that way, so you'll have a mark of where you need to refill it back to. I'm going to try to do that off camera in just a second. So, while removing the plasma with the pipette, you need to be very careful not to disrupt the buffy coat layer here. You can actually take off some of the platelets on accident. So once you've got that done, in your incubator, hopefully, you'll have some of the cell pack solution that we use for the analyzer. It's pre-warmed. And you'll use this to volumetrically replace the exact amount of plasma that you've taken off here, right back up to that line. So I'm going to go ahead and do that now. So now what you should have is some cells on the bottom and a bunch of saline up top. exactly at that line where you marked. You're going to take the tube, you're going to invert it a bunch of times to re-homogenize everything and make sure that the bread cells aren't sticking to the bottom. After mixing it 10, 15, a ton of times, make sure this is really well mixed. You're going to take this sample, you're going to run it on the analyzer, the same exact way you did before. Hopefully the results should look a lot better.
Post-saline replacement results clear up all of the asterisks for us. The results are much closer to normal ranges. A few of them still have flags as elevated or decreased, but our error messages have disappeared, indicating that our saline replacement was successful. We want to compare the pre and post saline replacement results to ensure that we haven't altered any of the platelet or white cell counts. When removing the plasma, it is possible to accidentally remove some of the platelets if you get too close to the buffy coat. In this case, it does not look like we have altered either of these counts from their original values. They are essentially the same across the board. In the case that you do get a much lower platelet count in your post-saline replacement printout, you will want to use the platelet result from the original printout. Hopefully this has been a helpful tutorial.